Thanks, Billy. Thanks, James. Persistent storage is a hot topic on Kubernetes. In this talk, Moritz Wanzenböck from Linbit will introduce Piraeus, a flexible and fast storage solution. He'll then use charms to set up production-ready storage for our cluster. It looks like everyone is nearly ready backstage, so here we go.
Thank you, David. Hello and welcome, everybody. My name is Moritz Wanzenböck, and I'm here to talk to you about using jumped operators for open source storage and how jumped operators make storage very convenient to deploy. About me, I'm a cloud engineer working here at Linbit, working on integrating our storage solution with cloud solutions. And to get started, I want to talk a bit about storage itself and how we used to think about storage and how it was used previously. So if you think storage, often you'll think about disks running in some server, or perhaps you have a file server that you use for storage solution, or you have a network attached storage, which you use to keep all your data safe. Or perhaps you're running in the cloud and you attach some virtual disks to your virtual machines and use that for storage. And what's common in all of these scenarios is that storage is something you configure at the server level. So you think about, I deploy some database on a server, and then I'll have to check which storage solution is available on that server, and have to think about reliability. Is my data secure? Maybe I need to create backups to a different location. And nowadays, when we move to the cloud, we have storage is kind of more fine-grained, because one of the things we do in the cloud is we split our applications in a bit smaller compartments, which we then call containers. And with containers, we have to think a lot more about which part of the container should be persisted, and which part is just the software we deploy. And then we can think about which kind of storage we use for the cache for our database, which kind of storage we use for the persistence of a database. Perhaps we have a message queue somewhere which needs persistence, and a different app which uses cache. And previously we had maybe deployed it all on the same server, and then it was clear, okay, there's only one storage solution available. But now we have the possibility to change all these parameters based on which kind of app we're running and what those apps need. And so when we think about all the different kind of features or parameters a storage solution can have, there are a lot of different directions we can optimize for. So perhaps if you're running a cache, you want to have your storage to be very fast, but you don't need it very, very reliable. Otherwise, if your customer database, it maybe doesn't need to be that fast, but you want to have it super reliable because you don't want to use any customer data. Perhaps you need it very secure because you have some, either because you just all software needs to be secure by default, or perhaps you have some requirements by law to not store any unencrypted data. It should also be maintainable, because every solution eventually needs some kind of maintenance, and if maintenance takes a very long time, then it's maybe not the right solution you want to use. And in a similar vein, the storage solution should be convenient. It should do all the things you would expect and want it to do. without too much hassle. And perhaps also it should be affordable, because the best solution doesn't gain you anything if you can't afford it, and you need some special hardware, or you would need to buy some special hardware which perhaps you can't. That's maybe also not good. And so if you think about cloud native storage nowadays, there are a lot of different solutions, and these on the right is just a small picture from the cloud native foundation on all the different storage solutions that they list, but they are of course not all. Those are just the ones that are open source. And from all of these storage solutions, one of the general takeaways I had is that the convenient solution, so those that are easily installable, deployable, and maintainable, are often quite limited. As an extreme example, all your cloud storage already have local storage, because there's an operating system running underneath the cloud, and that has local storage, and so you could just reuse that. But that is perhaps not the most reliable, because when then one of the nodes crashes, then you can't access that data anymore, and that's of course not good if that's your customer database, and then can't operate anymore. Also, if you're running in some hosted cloud service, then perhaps you think, I'll just use the cloud storage there. And then, of course, you're kind of locked into that one cloud environment, because migration is not that easy. And even if it's available, they have often some kind of weird limitations for where you can access that storage from. Perhaps it's only stored in one data center, and if you want to replicate it across data centers for reliability, then that's not easily possible. And then the other kind of extreme, that I call them now dedicated storage solutions, they are often quite complex, so they need a lot of setup and perhaps long instructions on how to use them. Perhaps you need to do a lot of manual steps to maintain and use them, and upgrades are also so complicated that you don't even try them. So that's of course also not good. And that is where charmed operators come in. With charmed operators and Juju, you can deploy these kinds of dedicated storage solution that cover a lot of different use cases in under 5 minutes, because they automate all the cumbersome setup and help with maintenance. Upgrades can also help with monitoring, see that your storage is still working. And charmed operators can also help with then later using that same storage. So charmed operators integrate with other charmed operators, and so you can just use them to configure your storage solutions however you see it fit. And so all in all, they make dedicated storage convenient. And to demonstrate that, I want to talk about Piraeus Datastore, which is the open source storage solutions we at Linbit develop. And basically the storage solution is not aimed at a specific platform, but is supports many different platforms. But with Piraeus, we're focused nowadays mainly on Kubernetes. And everything we build here is open source and freely available to use. Our main focus for our storage is to have it reliable and fast. So basically reliable, you don't need to worry too much about a node crash, and the storage should still be safe, and you can just keep on using it. And also fast, you shouldn't spend too long just waiting for this reliability. and we'll later see how that is achieved. And as a bonus on top of that, we have also very low resource requirements for our storage solutions. So that means it's also possible to run it on some kind of edge clusters, even on devices that don't have their own storage. And now for the jumped operators with Piraeus, I'll quickly want to jump into terminal and see that it actually deploys in under 5 minutes. So right here, I have a Kubernetes cluster set up with micro-K8s. And as you can see, there's 3 nodes, and currently there is nothing running on there. I've also set up the Juju controller already for micro-K8s, and we'll start using that right now. So the first thing we need to do, we want to deploy our storage solution in a new model, and just use the add model command, and from that we can quickly create an empty file called linbit secret, because if you're one of our enterprise customers, you could store your customer credentials here, and you would get access to some different images. But if you just create an empty one, you'll just deploy the open source variant, which is using all the different using all the same software. It's just enterprise packages have a bit more baked in. And now we can just deploy the Linstore, which is the kind of the heart of the Piraeus Datastore, and I'll quickly show you all the different things that will be deployed. As you can see, that's a bundle which deploys different kind of packages, and Juju is just working away on setting that up. And very soon it should be completed. And if you check the status now, you can see it's still working on installing the agent, which gives me time to talk about a bit about the components we have in there. So as I said, it's a modular platform which focuses on or integrating with many different platforms, and the core of all our storage solutions are DRBD and Linstore. DRBD stands for Distributed Replicated Block Devices, which is basically RAID 1 over the network, from one mirroring disks from one computer to another. And Linstore is a kind of management interface for all things Linux storage. And on top of that, we have the integrations with the CSI driver, which is the translation layer between the Kubernetes world, with its storage classes and persistent volume claims, and so on, with the Linstore world. And then, of course, our jumped operator, which we just used to deploy software that packages all these and configures all of them in the right way. So a bit more about DRBD. It's a kernel module in the Linux kernel, so it has very low overhead. And basically, when your app writes to a disk, and that is a DRBD configured disk, then all those writes are sent over the network to a set of replica nodes where all the same data is also stored on that server. And because it's in the kernel, super low overhead. Yeah. Linstore then is our programmable Linux storage, basically. So Linux already has a lot of different ways to configure storage built in. So there's the logical volume manager and all different kinds of caching layers and encryption layers. And basically, Linstore makes them convenient to configure and access. It supports different backing storage providers, as I said, like the logical volume managers on Ubuntu, also interesting ZFS. Also, different kinds of backing disks or self-encrypting disks are also supported, and so on. You can also then, if you create some storage, you can also create snapshots of that storage, including on schedule. So make a backup of your or snapshot of your database every hour so that you don't accidentally drop the whole database. Or if you do that, then you can quickly restore. And for disaster recovery, we can also create snapshots that are then shipped to an offsite location, which could be, for example, some object storage similar to Amazon S3, or a secondary Linstore cluster running on a different set of hardware nodes. And all of that is controlled by an API, which is used by our integrations like the CSI driver, which we will use today, or the client, which we'll also see, or we also have a graphical user interface, which you can use from your browser. And with that, let's check back in with our cluster and see if everything deployed as expected. And as you can see, it's still installing charms, but it should be done relatively soon. Let me quickly check in the meantime that everything the controller already, the operator already did. You see, this is the Linstore client. And if we, I forgot one important command before. I'm still in the normal namespace. So let's quickly check into the storage namespace where we deployed. And as you can see, the Linstore controller already registered all these different kinds of storage nodes. And if we check the storage pool list, you can see that we currently don't have any storage configured because we haven't told the operator yet where it can find the storage. But that we can quickly change with changing the config with Juju, and we'll set up a storage pool with the LVM thin provider and use this storage pool provider, call it thin pool. There is a P missing here. And then we can also specify which devices it should use. And let's use those. And if we check the status now, you can see the Linstore CSR nodes have now finished and the satellites are updating the configuration. And if we check on the storage pool side, it should be visible quite soon, unless I have created a typo somewhere in there. But I think that all looks good. Okay, apparently I made a typo somewhere here. Let's just copy that command. Oh, I used provider instead of provider name, so that was my mistake. And now it should update and resolve all of these error states. And if I check the storage pool, then you can see now the storage pool gets created fine, and we have about 100 gigabytes of free space for our storage. And now that's available on all. And now I want to quickly demonstrate how Juju also helps with integrating an existing solution with this new storage provider. And for that, we'll create a new model called database, and we'll create a new storage pool. Let's call it Linstore storage. And it's a type of Kubernetes storage pool. And then we also need to give it a storage class in Kubernetes. Let's call this Linstore storage. And then we need to tell Kubernetes the name of the provisioner, which is the Kubernetes name. As you can see, that's the CSI driver. And we can also specify some parameters here, like the storage pool we want to use, which is the one we configured previously. And we can also tell it to create 2 replicas of all our volumes. And that created fine. And then we can just simply deploy an existing charm that then consumes that storage. And let's use a MariaDB charm and configure storage there for the database, which should use this new Linstore storage pool, and give it 2 gigabytes. And check now, it's installing the agent. If we check the pods in the database storage pool, the operator is in the process of being created. It should just take a few moments, and now it should also have a persistent volume claim created with our new storage class. It's currently pending, but now it's bound, and is the pod already running? And now it starts the actual database pod, which is using our persistent volume claim. And take a quick look back on how this looks on the Linstore side. We can give us our list of resources. And as you can see, it created actually 3 replicas from, even though we specified 2, this is one of the special features of Linstore. It created 2 copies that are actually writing to disk, and one of them is just a tiebreaker, which is used in case one of these nodes goes down to determine which storage it can still use. And as you can see, it's currently our volume is currently in use on the one node 0, and it's still syncing up data, and it should be finished relatively quickly. As you can see, percentages are going up pretty fast, and our database is now running and using that persistent volume. And that is already all I wanted to share with you today. Thank you for your attention. If you want to contact me, you can check out the links in the slide or scan the QR codes. If you want to try the storage solution yourself, there's a link to the Charm Hub page, which also has instructions on how to install and deploy and set different configuration options. If you need enterprise support for the storage system, or you're interested in learning more about the storage products itself, then you can head over to linbit.com, where we have user guides, tech guides, and as I said, also enterprise support. And with that, get back to David.